Here we have a phylogenetic tree that is a graphical representation of the degrees of similarity between our operational taxonomic units, watch species. Rather than differences in their DNA sequences, we are basing our tree on their characteristics. This is a rooted tree, meaning the distance between watches is known, as well as their order of divergence throughout time. Starting from the left, we note the very first internal node, which represents a shared common ancestor between our outgroup and ingroup. At this point where the pomander diverges from all the others, we have an instance of cladogenesis, meaning the splitting of the lineage into two. The watches that constitute the ingroup share a more recent common ancestor, represented at this node here. Why is the pomander watch in the outgroup? Well, because despite the name, it isn't really a watch the way we think of them today. It is fairly small, but due to its spherical shape, it's not really suitable to be worn on a wristband, and it's a bit intrusive in a pocket. It also requires a key, and its host must wind it every 12 hours to keep it awake. Following another split, the Patek Philippe keyless winding pocket watch has developed this flat profile that allows it to fit easily in its native habitat, the pocket. It also requires no key for winding, and it only requires winding by its host every few days. Here we see anagenesis occurring, where a true wristwatch evolved directly within the Patek Philippe environment. We see pocket watches readily adapted as wristwatches. Beginning with the appearance of the early species pictured, these wristwatches became regarded as a separate species, which then continued to interbreed with pocket watches, readily switching between wristbands, chains, and armbands to accommodate the needs of their human hosts. Next, we observe cladogenesis, another lineage splitting event, with the Seiko Quartz ASTRON. This was the first quartz crystal wristwatch observed. While it may share visual similarities to the Patek Philippe species, its shared ancestry may be further back than you'd imagine, as it believed to evolve from early quartz prototypes of very different dimensions than your typical modern watch. In the case of convergent evolution, it again adapted to suit increasingly picky human hosts, taking on a compact size and high energy efficiency, requiring no winding but instead a replacement of its energy source every few years. At another lineage split, we find the Hamilton pulsar. It may seem very closely related to the Astron, but the pulsar evolved in an ecosystem on the other side of the planet around the same time as the Astron and featured an LED rather than analog face to interact with its human host. Beyond the split here, we see two more instances of cladogenesis with the Fitbit Charge HR and Pebble splitting from one shared ancestor and the Apple Watch SE and Samsung Galaxy 3 from another. And you see at this point there is a huge amount of survival pressure due to more selective human hosts, resulting in accelerating rate of mutation and resulting speciation. Both features more advanced LCD screens, but sadly for the Pebble, disruption in their ecosystem means that while many individuals are still alive and well, there is no longer a breeding population. The Apple and Samsung species you see here diverge from a shared common ancestor with an OLED screen. They feature similar adaptive advantages when finding a host, such as ability to connect to Wi-Fi and smartphones. Simultaneously, they are more costly to acquire and require 2 to 3 times more energy to sustain themselves than their more specialized LCD cousins, meaning the Fitbit and Pebble species continue to survive and find human hosts.